Alright, so now what we're going to do is look at finding the solution to a system of equations graphically using our TI graphing calculators. So what I'm going to do is go to a typical zoom that your calculator might be on. What we're going to be doing is graphing these two equations here to start with, 10x plus 5 and 5x minus 3. So what I've done is I've plugged them both in. If you didn't solve for y, you would have to solve for y to be able to plug them into your calculator. I look at my graph. This is the picture. Now these I can see look like they're going to meet down here. If I wasn't sure what was going to be happening with them, what I would go is to my table, which you can see the values are kind of crazy, so I'm going to go to my table set and change those to just go up by ones, and then look at my table. So this is y1, that's the 10x equation, and this is the y2, that's the 5x equation. Now I look that the y1 at 0 is a bigger number than this. Still a bigger number, still a bigger number, still a bigger number. So they don't cross anywhere there. In fact, the difference between here is 8, the difference between here is 13, the difference between here is 18. So they're actually getting farther apart, and that means this vertical distance, like at 0, this one's 5 and this one's 3. So negative 3 and up at 5, it's a distance of 8. They're getting farther as x increases. We're going this way along the graph, and they're getting farther apart. So if we go up, it looks like they're going to get closer to one another. So again, y2 is still smaller. And then right somewhere between 1 and 2, this is a greater value than that. This is a greater value than, and now this is a lesser value than this. So somewhere between x equals -1 and -2, they cross. All right, because see, -5 is greater than -8, -15 is less than -13. So at some point, they get close and cross. So now what I'm going to do is set my window so that I can see, I can only see these on the x, but my y value, I can't see these values. So I'm going to go to the window and change my y minimum to a something I can see. So I'm going to go to like a -20. And that should allow me to see them on my graph. So what I'm going to do is now go to calculate the intersection. I don't want to just trace it, I want to actually find it. So go to second, calc, intersect is what I'm going to do. So I'm going to hit the 5. First curve, it tells me right up here what it is. And I can't see my cursor, but I don't care. I'm going to enter. Second curve is this one, which gives me the equation. I'm going to hit enter. And then guess, I don't care. And there we go. The intersection is -1.6, -11. So that is the solution to this system of equations. That's where they both have the same x and y value at the same time. If I trusted my calculator, I could actually, just from a zoom of this, even though I can't see the intersection, I can still go to calculate. So second calc, number 5 is my option. First curve, it tells me which curve it is, even though I can't see. And it tells me which curve I am here, which is my second curve. So even though I can't see it, it still will solve it for me and give me the values. Now if you have multiple equations all plugged in and graphed at the same time, you got to be careful that you're selecting correct too. You can also use this to find the intersection of crazier lines or solutions to more difficult systems of equations. So let's say we had something that modeled 5x minus 3 and another model that was x cubed minus 4x, and we wanted to solve that system simultaneously. What I'm going to do is go down and turn on this equation so they're both on. I'm going to graph it. It's probably not going to look that great. Actually, it looks pretty fantastic. So we can see they cross here, but it looks like they may cross down low and may cross up here. So what I'm going to do is just play with my window values so that I can see more of the graph. So again, I'm going to go to a -20, and how about 12-ish? Let's see how that works. Beautiful, perfect, almost like I planned it. I actually didn't, but that worked out nicely. So now what I'm going to do is I'm going to go to second calculate, and for this one, since they hit multiple times, I definitely want to see where it is on the graph. Alright, so I'm going to go left and right moves it sideways. And if I go, looks like they meet around here at x equals around -3. So I'm going to go way past that. So I'm definitely past their intersection point. Hit enter. Second curve is the cubic guess, and it gives me the curve. And see, the cursor is right on there. Maybe I should let us see a little bit more of the graph. See, I told you I didn't plan it. So I'll do that again. So calculate. So if I want to know where this intersection is, I'm going to go past where they meet there. That way I guarantee that I find that intersection. And you can see the cursor. Oh, damn it, covered up again. But there's the cursor. Alright. So now what I'm going to do is find this next intersection. Second calc. I'm going to go up here. Enter. I'm going to move over. Actually, let me see if it gives it to me now. So it did find indeed that intersection, which is now 0.337 blah 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 x and -1.31 blah 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 y. And then my third intersection, if I want to find it, let's say I cared about the solution to, all three solutions to this system, I would have to go more to the right. Now let's see if this finds it. That still found this one, so that wouldn't work. What I got to do is go to calculate, intersect. My first curve is this, and then I'm going to trace this till I get past where they meet. Now it found the intersection point I was looking for over here, 2.81 and 11.08457. So that's just one method of solving a system of equations simultaneously, and especially useful when they're kind of crazier equations that you guys aren't necessarily used to dealing with or solving algebraically.